Just walk you through the histogram first. You could use the NumWorks to support constructing this graph, so you're not really left to your own devices. Pun may be intended. I'm not sure. See if I have my cheap backup pen. No. All right. So what we're going to do is we're going to use NumWorks to help us come up with reasonable intervals. So to help us avoid having to actually count, like this number falls in this interval, that number falls in that interval. We're going to use NumWorks to do that for us. So I'm just going to go right to my home screen. All right. So I got in the habit of just always hitting this little back jammy here. You keep hitting that, eventually it brings you to the home screen. You could also hit the home button, which I think probably makes a whole lot more sense than what I do. It's just a force of habit at this point. All right, so we're going to go into statistics. I have some data there from another class. So what I'm going to do is I'm going to clear out this data. All right, so if you have stored data that you want to get rid of, you're going to go right on up to value v1. You're going to hit the clear button. Well, it's really the backspace button, but it says the word clear on it, so hit that. It'll ask you to confirm that you indeed want to clear the data. So you hit OK. Or execute, either way is fine. It means the same thing, right, at least in this context. All right, then we type our data in. I'm just going to keep trying. Oh, now it worked magically. No explanation. All right, so I'm going to type in my 80, 91, oops, avoid stray keys. With the touchscreen, it's very easy to, whether it's phone or iPad or whatever, it's very easy to hit the wrong thing. Like with the actual physical keypad, it's a little bit different, a little easier to get into the calculator what you intend to get into the calculator, but for this it's very easy to kind of go a bit astray. You're going to hit stat, calc, I'm sorry, stat edit. Apologies for that. I have my TI here. So you'd hit the stat key. It brings you up to edit. So hit enter for that. And then I have some data in here. What you would do is you go up to the column heading, hit clear, and then enter if you need to wipe out information. I'm just going to do that for all of it that's in here. No problem. All right. I'll just kind of tuck this off on the side so I don't forget to actually talk more about it. All right, so I got up to 90, the first 95, so another 95, 100, 0, another 100, 75, 75, 56, 42, 25, 11, and 55. And again, just got to be careful because you don't want to make a tiny little error in data entry and pay the price for it with every problem that you have to answer based off of that data entry. All right. I could tell you that, I mean, we're getting closer to a test. We're not there yet. But when, especially for the first unit, when I give you a data set, I'm using it to ask you like 4 or 5 questions. All right. So triple check that you typed your data in correctly, because 4 or 5 questions are relying on the fact that you typed it in correctly. So be very careful about that. So let me just kind of smidge this a little bit further. Let me talk to you about the histogram on the NumWorks. So you go all the way up. You see the option graph. So you're going to hit the right arrow to graph, then hit OK. The calculator is going to remember the last thing you did. All right, so the app that I'm using here is the same as the mobile app that you would use on your phone. So you saw how I had data previously stored from earlier today. It doesn't wipe it out. All right, so that and also previous graph settings are gonna be maintained. So I'm gonna hit OK on graph and then OK on histogram. and your histogram may look a little bit different than mine. That's fine as long as it's the way you want it to look. I mean, you can only control so much. I mean, you can't control the physical distribution of the data, but you can control how it's presented. All right. So just a note at the bottom of the little, what you call it here, the horizontal axis. Below that, you see in this gray area, gives us some information. First, the V1N1 tells us that this graph is a graph of the information stored in V1N1. All right. When we typed numbers into V1, it automatically populated a 1 for each of those values in N1, which is correct because I typed in an 80 once, so that's the frequency for that, a 91 once, and so on. All right. Across from that horizontally, intervals 0 to 10. You see how in my graph, most of them are shade of pink, but there's one that's orange. That's because that's the one that we're actually physically on at the moment. So if I hit the right arrow, it'll move me. Oh, sorry, I forgot. Bouncing back and forth between screens. You'll see how the orange goes along with each keystroke to the right, each relevant one anyway. All right. And you can see how the interval changes along the bottom, 0 to 10, 10 to 20, 20 to 30, and so on for every step along the way. And adjacent to that, you could see frequency of 4. That's telling me how many values make up that bar, right? What the height of the bar is. It's 4 units. This one's 4 units. That one's 3. It skips over the zeros, right? But if you see an empty bar, you know, like a little gap that doesn't have a bar in it, that must mean that there are no values in that interval, right? This one has a frequency of 1, and so on. Now you could change this because I'm looking at it from, you know, like let's evaluate the data standpoint, but then also let's get full credit on a test standpoint. So, you know, there's kind of a balance between the two. And I don't know that I would want to make this many bars on a graph. Right? My requirement is that you have to have more than 3 intervals when you make a histogram. All right. So this one has 1, 2, 3, 4. The blank space there is 4, 5, 6. Another blank space. So that's 7, 8, 9, 10, 11. I think 11 bars. I don't want to have to draw that. I want to draw like 5. So what I can do is go into my settings. It grays it out for some reason. I don't know why. Maybe because it's in flux. The bin width here is 10. The bin width is how wide you want the interval to be to capture data. So what this is saying is, if I just go back, that it's counting up every value, starting with 0, and going close to but not reaching 10. That's what that interval notation means. The bracket includes the number. The parentheses exclude. So when I have 0, 10, the bracket on the 0, it's saying start with 0, any number. So if 0 is there, you count it. 1, 2, decimal values in between perhaps. 3, 4, 5, 6, 7, 8, 9, 9.5, 9.75, 9.9999, but not 10. Right? It cuts it off right before it would hit 10 because the next interval starts off at 10 and goes all the way up to 19.99999 and so on. All right? So I don't want to do this. I want to have it wider intervals to make my life a little easier. So I go to settings. I still want it to start off at 0, the X start. Well, I have a 0 in my data set. And even if I didn't, 0 is a nice number. It's good to work with. All right, so I'm going to make my bin width, I'm going to make that 20. It was 10. You might have had 4 and 1, you know, like 15 and 9, like depending on what the default value was, or if you had used it before for something else. It all depends. It just remembers what you did. So I'm making mine a width of 20 and an X start of 10. I hit OK on confirm, and now I have something that I'm a little bit more willing to graph. All right. So for the frequency table, first thing we would do is state our variable. Here they didn't tell us a variable name, so they didn't give us any context. So I'm just going to call this a list of X values. See, right? Because why would it continue to work? It was working. It was working. You saw it, but nah, not anymore. So fleeting. All right, so I'm going to call this X. All right, so that's my random variable, well, not random, it's just variable X. And that's going to be the title of this column. All right, the other column is going to be titled frequency. You can abbreviate that. As long, my stance on abbreviations, as long as it's obvious what you're abbreviating, it doesn't really matter. All right, so you just call it F if you want, X and F. All right, I will take certain things for granted or on faith. You know, like if you're making a frequency table, that you know that one of the columns should be frequency, otherwise how is it a frequency table? All right, but looking at my intervals here, my first one goes from 0 to 20. All I'm going to do is I'm just going to write where it says interval. I'm going to write that in my table the way they have it there. So 0 to 20, then 20 to 40, and you can follow along, but the interval should be consistent. So 40 to 60, 60 to 80, 80 to 100, and then the last one, you know, it may not feel right, 100 to 120, but it is technically a correct interval. Intervals should have consistent width from beginning to end. So if your first interval is going by 20s, your second one should go by 20s, your third, your fourth, your fifth, however many. All right. The last one feels kind of weird because there are no values between 101 and 119 in the data set. So we actually created an entire interval just to account for the 100s that are in the set. All right. So it might feel weird, but that's the correct way of doing it. Then I want my frequencies, corresponding frequencies. I got 2. I got 1, 4, 3, 8, and a 2. All right.
Question.
Sure.
We're never gonna have to touch the what we just did to make it smaller bandwidth. Is that what it was? Again, like, are we gonna have to alter it based on the data set, or?
Yeah.
Yeah. Okay.
Yeah, because if I give you a data set that has like decimal values between, like, let's say they're going from 1.1 to 9.87 or something like that.
Oh, then you have to put it into 10.
Yeah, you want to go by ones, or you want to go by tenths or half units or whatever.
Okay.
Yeah. So what I recommend is just letting the calculator do it first, see what it comes up with, and then make an adjustment from there.
Thank you.
No problem.
I have a question.
Sure.
For some reason, I'm never getting, no matter how many times I put the numbers in, I'm never getting the same thing you're getting. Like as far as like relative at the bottom and stuff, my thing is always like a little.
A little off or a lot off?
Yeah, a little off. So like when I go to the one on 120, you have 0.1, I have 0.095238. I don't know why that's happening to me.
It usually is a data entry issue. Can you double check your data and make sure it was typed in correctly? Because sometimes just even a slight error.
I have 80, 91, 90, 51, 75, 75, 83, 83, 80.
Oh, you got an extra 75 in there.
I put an extra 75?
Yeah.
Okay. Okay, good. Thank you.
No problem. All right, so now on paper, I just want to make the graph that I draw look like the one that's on the screen. And really, I mean, you can just kind of go by what you see on the screen. Right? My tallest frequency, my largest frequency, so my tallest bar is 8. So I would want to go up as high as 8 on the vertical axis. And then I'll create a scale from there. Right? So half of 8 is 4. Half of 4 is 2, and then half of 2 is 1. So now I know what 1 unit along a vertical axis looks like. So now I have the spacing. I prefer to do it by going half units, because then you have a consistent scale. Yeah, it may not look pretty, especially since I'm writing it with a finger, but it should have close enough spacing that you can generate a graph that looks like what's on the screen, all right, for the calculator. You also want to label this, label it frequency. All right. Now my horizontal axis, that's got to have a label too. We're going to call that label just X. But just bear in mind, if you're given context, if these were scores on a math test, you would write scores on a math test, right? Just what the particular variable represents. And then just looking at the scale that's established there, this goes from 0 to 120 in 20 unit increments, all right? So I can go 0 to begin, 120 to end. Right down the pipe here is 60. Break 0 to 60 into thirds, so boom, boom. Not quite close enough on the boom there. All right, so just in the neighborhood, we should have consistent width along the way, but again, it's not, well, again is not the right word, but it's not an art class. I'm not looking for perfection here. I'm looking for you to show that you can construct it and label it the right way. All right. And we have the heights. The heights are in the frequency table. All right. But you could also, if you want, you just scroll back and forth, the height of 2, height of 1, and so on. All right. So height of 2, height of 1, height of 4. So shoot it on up to 4. Height of 3. All right. Height of, this should be the tall one, yep. Height of 8. And a height of 2. All right. It's a pretty disgusting looking graph, but it gets the job done. Now you see how I made it like extra disgusting at the top there? I didn't really do that on purpose. Like it's all kind of like wonky. If you ever have a graph that's like that, like you get like a shaky hand. I mean, this is good compared to what I would do on paper. It's like, it's not good. Let's just put it that way. If there's ever any uncertainty as, like you look at it and say, I'm not sure he's going to know I made that go up to 8. Like he's going to think it's a 7 based on the way I drew it. All right, then if that's the case, then just put the number inside the bar. So 2, 1, 4, 3, 8, and finally a 2. Just so I know what your intent was. So even if you missed the mark, not a big deal, especially since this one only goes up to 8. What if it went up to like 80? And you had to distinguish between 79 and 80. That's a tiny little bit of distinction there. Yeah, I should anyway, unless they cleaned out this test. Yep, got a lot. There you go. You're welcome. All right, so that's the frequency histogram. It's really all you need to do to construct one. But in terms of talking about things like measures of center, measures of spread, shape, any outliers. Outliers are better determined if you use a box plot, so I'll get to that in a minute. But you can discern here that this seems to have a left skew, right? So appears to be left skewed. Right? When the bulk of the data is on the right and it kind of tails off to the left, the direction of the tail is the direction of the skew. Right? So here, I mean, it might be a little, I'm not so sure, but at least the way I drew it on paper. But if you look at the one that the calculator generated, it's a little bit more obvious that most of the stuff is on the right and it kind of feathers off to the left. Right? You could also have something that's right skew, which would be the mirror image of that. You'd have lots of values over on one side, maybe something like this, and then like that. This would be an example for right skew. All right. Symmetric should be fairly obvious. It's equal parts left side and right side. All right. We're not actually going to use this little L here, so don't worry about that. We're just still in the room. I'll just draw an example of what symmetric might look like. Now, in statistics, nothing is perfect. So when I say something is symmetrical, I'm really implying that it's approximately symmetrical. All right, so this one is, I'll just say symmetric. All right, symmetric, symmetrical, whatever. But you can see the heights aren't precisely the same. I mean, there's nothing precise about any of this, the way I'm drawing it. But it doesn't have to be perfectly symmetrical to say that it's approximately symmetrical. We tend to say it's symmetrical enough to do whatever statistics we want to do on it. All right. So, and that's the case with normal distributions. It's the case with a lot of things. In most math classes, you're looking for exactitude. In this class, oftentimes close enough is good enough. All right. So we'll address that further as we go. But let me do the box plot with you. Same data set. Good thing about a box plot, the numbers that make up the five number summary, they're also values that are used to determine if there are any outliers. Right? So it's kind of like a double whammy, which is good. Right? But we do want to pull the 5 number summary. When I think I made the practice test available, so you can look at that on Brightspace. I'll send the reminders out, but you'll see on there that one of the questions is to make a box plot and state the 5 number summary. All right. When I give a practice test, I'm basically giving you the format of the actual test. So if question 1 on the practice test is construct a histogram, which it is, along with the frequency table, if that's how it is on the practice test, that's how it is on the real test. All right, so you will have exposure to the types of questions that you'll be expected to answer on the actual test just by going through the practice test. All right, first question is to make a frequency histogram along with a frequency table. The second question is to make a box plot and state the 5 number summary. So I'm really showing you how to answer questions number 1 and 2 on the test right now. All right, the good news is when you have a set of data and you're using that set of data to answer multiple questions, most of the time you're just 1 or 2 keystrokes away from getting the information that you need. So I want to make a box plot. So what I would do is I go to type, so right from within the histogram, actual graph, I go to type, hit OK, and just change it to say box plot instead of histogram. All right. For box plots, the possibility is you could have it set to display outliers, or you could have it just set to just show the entirety of the box plot. All right, so we go into settings and make sure display outliers is turned off. All right, so this is a little notation here. Display outliers equals off. And I'll take you through the TI stuff in a couple minutes, just I got to put the data in there and run through it. All right. We want this to be off, but you could be faced with a question and ask you to identify outliers, in which case you'd want to turn it on, but we're not turning it on to construct the box plot. We're turning it on for other reasons. All right. So I hit that little back jammy there. They give me the scale at the bottom, which is nice. I mean, you can be a little bit more precise with it if you want, but the first thing I'm going to do is I'm going to take note of the minimum, the Q1, the median, the Q3, and the max. There's another menu where you could pull this information, but you could also get it right here, so why not? I mean, this is better because you not only get the value, but you also get an idea of what the graph looks like. Right, and you can see there the tail of the box plot is off to the left. That tail on the left is longer, much longer than the one on the right. So this is another way of representing a left skew. Wherever the tail is on the box plot, if that tail is longer than the other tail, so you have two tails, left tail, right tail. If the left tail is longer than the right tail, it's got a left skew. If the right tail is longer than the left tail, then it's got a right skew.
What tails are you talking about?
That tail
Okay.
versus that tail.
Okay. Glad I asked you.
All right, so my minimum 0. 53 is my first quartile, also known as Q1. 77.5 is my median. 90.5, 90.5 is my Q3. And my maximum is 100. Like I said, they gave me a scale, which is fine, but if I'm going to estimate where 77.5 is on the graph, I think I probably want a little bit more precision. So I'm going to go with 0 here, 100 over here. Oops, sorry. All right. So they broke it up 40, 60, I'm sorry, 40, 80, 120. I think I just need to go up to 100 because that's my maximum. So I'm going to do that. All right, I'm going to put the 50 right in the middle. If you're comfortable with quarter units, you could do that. So 0, 25, 50, 75, 100. Otherwise, break it up by 10. So 10, 20, 30, 40. Then I have the 50, 60, 70, 80, 90. All right, you have to have a measurable scale in that I have to know what each tick mark represents. All right, so up in space above the number line, I'm going to plot a 0, a point at 0, I should say. Then 53, it's still estimation. 53 is somewhere between 50 and 60, closer to 50. Not by much, but a little bit. So here's 70, here's 80. Let me, I'll use a highlighter there. 70, 80. All right, so 77.5 is going to be directly between, or a little bit to the right of directly between 70 and 80. So we're talking about like right in this neighborhood here. Doesn't have to be perfect. Just got to get close enough. Close enough is good enough. 90.5 and then 100. Make a box around the middle 3 points. And let's see if I can do a better job there. All right, vertical line through the median. And then extend out to the extremes. And that's my box plot. And it looks enough like the one that's on the Numworks that I'm pretty comfortable with it. I have a nice scale at the bottom that's obvious. And again, this is a left skew. The act of constructing a graph doesn't tell us anything about analyzing it. It's not saying, well, anytime you construct a graph, you have to state the skewness. I'm just telling you that on the test, I'm going to say, follow-up question, does this graph have a left skew, a right skew, or is it symmetric? And based on what we're talking about here, you should be able to answer it. Right? But let me switch gears for a minute and talk about the TI. All right, those of you who like that, maybe you don't like it, but that's what you got, and that's what you're comfortable with, and that's what you want to do. Perfectly fine. I have the data written again down here. We're not going to do stem plot, but I'm going to it's the same data set, so I'm just going to pop it in here. 80, 91. $75. One of them didn't lock in. All right, so it should be 90. 51, 75, 83, 83, 80, a couple of 95s, 100, 0, another 100. There's definitely with this emulator that I'm using, there's definitely a little bit of a lag, so just bear with me on that. Let's see if I can make it a little bigger too while I'm at it. Not really. All right, so 75 twice. 56, 42, oops. 42, 25, 11, and 55. So 25, 11, and then 55. All right. Ultimately, it's going to give you the same information when you do the box plot on the TI as it does on the NumWorks. You'll be the judge of whether it's better or worse, the same, right? So I'll just make a little note here on the TI. You'd hit second y equals. All right, so the second key followed by y equals. It brings you to stat plots. All right, so then hit enter on plot 1. All right, so I'm just going to say select plot 1. All right, you do that by hitting enter or just the number 1, either way. Turn it on. It may already be on. The default is to have it on, but you never know. Right? If it's not on, you can tell at the top of the screen here. See, you have bolded around plot 1, plot 2, plot 3. If this were off, let me just do it again here. You see, you'd have plots 1, 2, and 3 off. You'd go in, hit enter, and then hit enter on the word on, and then it'll lock it in there. All right. So then you'd hit the down arrow, and you have a few different types of graphs that you can work with. We're looking at the box plot. All right. So I know it's hard to see, but there's 2 box plots. One with a couple of loose points floating around there. That's the modified box plot. That's what you would select if you wanted to display outliers. All right. So we'll get to that in a minute, but we want the ordinary box plot. So I select that and hit enter. All right. And then I'm going to say select box plot. I'll just draw a little box plot and then hit zoom 9, which is zoom stat. All right, so you'd hit zoom, and then you see one that says option 9, which is stat, zoom 9. Either scroll down to the 9 and hit enter, or just select the number 9, and it'll make the graph. You have well, you don't, I do, have a stray equation there. That's because I have something stored in my ordinary y equals. So I have this, I'll just clear that out. Go back to my graph, and now I have my I have the graph, now I just need my 5-number summary, which I can get. Let me just do the zoom 9 again. If I hit the trace button, all right, so I hit the trace button, it puts me on the box plot, and then I can scroll left and right, and it'll show me the minimum, which is 0, first quartile 53, median 77.5, upper quartile 90.5, and the maximum, which is 100. All right. So again, you hit trace, and scroll. All right. That unfortunately, it has many more steps than it does on the NumWorks, but it accomplishes the same thing. There are some things that the TI does better than the NumWorks, right? So we'll cross that bridge down the line. It's not really anything that's necessary for the course, so I just kind of I encourage people to just stay with the NumWorks. But if you love your TI and you don't want to move off of it, I'll still give you what you need there also. And just going back a sec, if you needed to do we did a box plot. If you needed to do a histogram, all stat plots are in the same menu, stat plot. So second, y equals, I just tend to work inside plot one and just kind of leave it there. You could plot multiple graphs at the same time. I just find that it gets a little confusing if you don't have one of the color screen TIs, right? So which is, you know, most of them. So I'm just going to work out of this one, hit enter, and then go down, select the one that looks like a histogram, hit enter again, and then zoom 9. Whenever you create a stack graph on the TI, zoom 9 is the way to go. And same deal, hit trace. It'll give you the interval 0 to less than 20, which is equivalent to what we wrote, 2 values, 1 value, and so on. It's the same graph, right, that we created with the histogram on NumWorks. Right? It gives you the same information, just go about it a little bit of a different way. You know, the fact that different features are stored in different apps on NumWorks might be a kind of a turn off, right? So it really all depends on what your preference is. You can go either way with it, right? The thing about NumWorks, again, I mentioned this last time, I forget, but if you're using the NumWorks on your phone on the test, I just got to verify that you're in airplane mode, right? So it's got to be a calculator when you use it, all right? It can't be anything else, not during the test, all right? So yeah. Anyway, the last statistical graph that I wanted to talk about, not the stem plot, but the dot plot. All right, stem plots have their place, I guess, but I can say just from having taught statistics since the dawn of time, the year 2000, that I've always taught stem plots, and then as the course would progress, we actually never did anything with them. All right, but we do a lot with box plots and histograms. Dot plots is kind of like a little bit of a trade-off where you sacrifice precision with the hope that you can get a better idea of a distribution of data very quickly and easily. All right? Easy or easily is a relative term, so you'll be the judge of that. What we need to do, and honestly, I don't know that this data set is best suited for a dot plot. Let me just make up a quick set of data. All right, so I'm going to say example. It doesn't matter. I'm going to go 1, 1, 2, 2, 2, 3, 3, 3, 3, another 3, 4, 4, 5. Come on, stop moving. 5, 5, and 6, 7, 8. And just values that I just made up off the top of my head, or at least the distribution anyway. Dot plots are really useful when you have whole number values and a small set of data, right? Because if I had 1,500 data points, I'm not making a dot plot. I'm not even typing that into a calculator to use all the stuff that's stored in the calculator. I'm using something more powerful like Excel, something that has the capacity to handle that. And the hope is that I wouldn't actually have to type all that information in, that I'd have some apparatus to be able to handle that for me. All right, so what we do is we create a number line going from the minimum to the maximum. I got a 1, I get an 8, 1, 8, 4 down the middle, 2 down the middle of, halfway between 1 and 8 is not 4, so I'm going to actually make it go from 0 to 8, because I mentioned before 0 is a nice number to work with, and it's for reasons like this. All right, so I could go 0 to 10 if I wanted, but I'm going to go 8. All right, so 4 in the middle, roughly, maybe a smidge over. Halfway between 0 and 4 is 2. Halfway between 2 and 0 is 1. So now I have my scale. Do the same thing on the high side. Right. Now you may look at it and say, well, why do I have to do it that way? Nobody's telling you have to do it that way. All right. I like doing it this way because it uses most of the number line, And so I figure if the teacher drew a number line that was that wide, the expectation is that you'd use it. So I suppose you could be like 0, 1, 2, 3, 4, 5, 6, 7, 8, and then not use any of this. That seems like a waste. All right. So yeah, we want to utilize as much of the given number line as possible. So all we're going to do is, at a designated point in space above the number line, we're going to plot a point for each number that's represented there. All right, so I'm going to plot a point here, this distance here. So this is the distance I'm referring to. All right, so going from here down to the number line, that's what 1 unit looks like. All right, I have 2 ones, so that same distance that I have going to the number line, I'm going to have that same distance above, roughly. All right, so 1 unit, 2 units up. All right, just plotting points in space. And all that's doing is establishing consistency from data point to data point. So at 2, well, I have 3 2s, so I'm going to do 3 dots equally spaced, roughly, above the number 2. I have 4 3s, so 4 dots equally spaced above the 3. 2 4s, so 2 dots equally spaced above the 4. 2 5s, so 2 dots equally spaced above the 5. 1 dot above the 6, 1 dot above the 7, 1 dot above the 8. Roughly, the whole idea behind a dot plot is supposed to be kind of a quick and dirty way of plotting points. It's not supposed to be some kind of art form. Right? Even our histogram wasn't, you saw the one I made. Right? The whole idea behind a dot plot is to be able to get a sense of the distribution without wasting time typing stuff into a calculator. You're like on paper, and you're like, oh, okay, I see it's skewed to the right. All right. I've noticed that people in the past have, I don't want to say they struggle with the concept of skewness when it comes to things like dot plots and histograms. It's just there tends to be a lack of certainty. But when you're given a box plot, I actually said it right. Look at that. When you're given a box plot, it's often much more obvious. All right. That box plot is asymmetrical. The tail on the left is much longer than the one on the right. But if I compare it to the histogram, you might say, well, yeah, it looks like it's got a tail to the left. I'm just not really sure. Is that enough of a tail to say that it's left skewed? I'm not really sure. But it really kind of yells it at you with the box plot. Right? Same idea with the dot plot. You see it's tailing off to the right, but you're not sure. If you're ever unsure, even if you're asked to do a dot plot and you're talking about skewness, type the data into the calculator and see what the box plot shows you. Right? So I can do that real quick. This is a nice clean set of data, so confirm. I could actually put this in as a frequency table if I want. Right? Because if I type the number 1 here, it comes up with a frequency value of 1. I could type the number 1 again, and then it'll give me another frequency value of 1 for a total of 2. So if I add these 2 frequencies up, I'll get 2. That's saying I have 2 1s. So the question might be, well, why not just say I have 2 1s? That's what the frequency column is telling me. All right? The 2 occurs 3 times. The 3 occurs 4 times. The 5 occurs 2 times. So make that adjustment. Instead of typing in the 5 twice, instead of typing in the 3 4 times, type in the 3 and put a frequency of 4. 6, 7, and 8 all occur just the 1 time. All right. Now, just thinking about it, I just typed that data in. Yeah, I made use of the frequency column, which is great. I could have made that graph by hand before I even finished typing in the data in the so that's the benefit of doing a dot plot. All right. But then I go to graph. If I'm just concerned with skewness, I'll go to box plot. Yeah, it looks like it has a tail to the right. That tail on the right looks longer than the tail on the left. It's definitely not symmetrical, right? So longer tail on the right means skewed right, right? If I wanted to look for outliers, I'd change my settings to display outliers. If there's no change in the graph, then there's no outliers, right? But if I wanted to look at the histogram, I'm sort of at the mercy initially of what the calculator decides is a good interval, but this is reasonable. Right at the bottom it says 1 to less than 2, which means just the number 1 because I don't have any decimal values, so I have nothing between 1 and 2. And this interval is excluding the 2, so it must be my set of 1s. And if you compare this distribution to what I have on paper, I mean, it gives you a sense of the shape. Right, so we have 1 is less. Actually, it seems to be missing 1. Did I forget to type in a value? Oh no, I think I forgot to type in a value. Yeah, I missed the 4 along the way. I'll just kind of throw it in at the bottom. 4 occurs twice. All right, now go into my graph, and now it looks the same, roughly. No, actually, not even.
Did you put 4-1?
I did put 4-1. Okay, thank you. Ah, there it is. Oh, because I didn't. Okay, you got to hit OK before you hit the backspace. All right, it's more of a me problem than anything else, but glad to figure it out. All right, so this distribution has the same shape as the dot plot that we constructed by hand fairly quickly, I would say, and it's really reinforcing what we have there. Right, 2 values that are 1, 3 values that are 2, 4 values that are 3. And so on down the line. All right. So the benefit of a dot plot again is that you can get a quick and easy idea of what the distribution of the data set is without having to go too crazy with the calculator. All right. On the next page, I have the different types of symmetry, skewness. All right. So this is pretty important stuff because I've been talking about it. So you definitely want to be mindful of that. I have a description of how to do graphs on the TI. If you have a TI and you want to do that, you're welcome to do that. More than welcome, you probably should do it. But if you're a NumWorks person, then you shouldn't have to touch on any of that stuff. All right.